In week 6, we're going to talk about making decisions. Thus far, our programs have executed from the top and executed every single line of code. Making decisions allows us to execute some code over other code. So sometimes when we run our programs, not every single line of code is going to be executed, depending on what kind of decisions we need to make. So the first thing to go over in this section is talking about logical variables. So a logical is just true or false. It's another type of data we can have. We have doubles for numbers. We have characters for strings. A logical is just another type of variable, and it can store two possible values, true or false. True is represented by 1 most of the time, but it's really any non-zero number. False is represented by 0. So anything that's 0 is false, anything else is true. And logical variables are created when we start asking questions and comparing data. So first thing we want to know is what kind of questions we can ask. So the kind of questions we're going to ask relate to these operators right here. We can ask if a variable is less than a number, if it's less than or equal to a number, if it's greater than a number, greater than or equal to, if it's equal to a number or not equal to a number. So one thing to keep in mind, less than or equal to, greater than or equal to, and not equal to. These are two different characters that make up one operator. So there's no spaces. Make sure you type both of them. Another thing to note is equal to is not equal to assignment. Make that proper notation. Not equal to assignment. So equal versus equal. So this one is comparison. This one is assignment. Common error, so make sure you're paying attention to which one you're using. So those are the types of questions that we can ask. We can also ask more complicated questions. So here we can only compare two values at a time. If we want to ask more than one thing at a time, then we need something called logical operators. So the result of these operators up here is a logical. So if I say 15 greater than or equal to 50, this is obviously false. So my answer here is going to be 0. So it results in a 0, which means false. If I ask another question, 15 less than or equal to 50, this is obviously true. So this results to a 1, meaning it's true. So these result in a logical. Relational inequality operators result in a logical. Logical operators combine two questions together. So it asks, is this true? And is this true? We have question 1 and question 2. Or we have question 1 or question 2. So that's what and or are. This is and. Oops. This is or. If you want to know how to type this bar here, this is called a bar, you need to do shift, the shift forward slash or backslash, whatever one that is. It's the one above the enter key. So we logical and, logical or, question 1 and question 2, question 1 or question 2. We also have not. Not works like this. Not true is false, and not false is obviously true. So that uses one, it asks one question. So it only has one operand is what we would say. And then XOR checks to see if they're different. If you ever want to look to see how the and or operate, then we can use something down here called a truth table. And I'll talk about the difference between a single ampersand and a double ampersand, possibly in class. So here's our truth table. So here's question 1, here's question 2. And it shows you, depending on our questions, what the answers are, what and, or, XOR, and not are going to be between them. And essentially is going to be true, checking if both are true. If both question 1 and question 2 are true, then it's true. If one of them is false, then it's false. And if both of them are false, then it's obviously false as well. So and checks if both are true, or checks if one is true. So if they're both false, it's false. But if one of them is true, then it's true. And then if both of them are true, it's also true. XOR checks to see if they're different. Checks to see if they're different. So if they're both false or both true, they're not different, so it's false. But if one is true and one is false, then it's true. Sometimes we use XOR, we won't really see it in this class. And then not, like I said, turns false to true and true to false. So that's our truth table. So if I had true and false, then my answer would be false. But if I had true or false, it would be true. Because and looks for both of them, or looks for one of them. So we can use these relational equality and logical operators for both scalar values and arrays. When we compare scalars, a scalar logical is produced. So for example, if I say 15 greater than, or equal to 50, I get one answer. That's false, or 0. But if I compare a whole array, if I say 17, 42, if I compare this whole array and ask, is this array greater than or equal to 20, then I get a whole set of values. I get a whole set of what's called logicals. My true false answers. It's going to compare each one at a time. So it's going to say, is 1 greater than or equal to 20? The answer is false. Is 20 greater than or 15 greater than or equal to 20? False. 25, true. 62, true. 17, false. 42, true. So it's going to give us a whole bunch of logicals where it's element by element. And then if I have two arrays, it will also do it element by element as long as they have the same size. So if I do a 2 by 3 greater than a 2 by 3, it will do element by element comparison, which can be useful within our programs. So this is for numbers. We can also compare strings. It depends on the type of string we have. If we have string scalars versus character arrays. For string scalars, remember these are double quote arrays, or double quote strings. I'll rewrite that. Then we can go ahead and compare our strings using the normal relational operators that I talked about up here. We can use these ones up here. So it's really nice because they behave just like numbers. So I can say, is string 1 equal to string 2 as long as they both have your double quotes here. If we want to do case insensitive, there are functions that allow me to convert a string from uppercase to lowercase or lowercase to uppercase. So here, if I do lower, it converts all the text to lowercase. There's also a function called upper that converts it all to uppercase. But if I want to do case sensitive or case insensitive, I can go ahead and use the lower function in order to compare my two strings. If we have character arrays, so these are single quote. There's single quote text. Then it's an array. So if I have map equal to, pop, then it's going to do element by element operations. It's going to compare M and P and give me a false. Compare A and A, or A and O and give me a false. Can we compare P and P and give me a true? It's going to do element by element just like it did up here. So if we don't want to treat it that way, or if we have two character arrays of different sizes, so this will not work if our text has different sizes, then we want to use something called the string compare function. So strcmp should be used to compare two character arrays to see if they're equivalent, especially if you have different sizes. Because if you didn't have different sizes, then it's going to give you an error. So if it says map equal to maps, it will say error. because they're not the same size. Okay, so that completes all of the different operators we're going to talk about in this class. So we have math operators, we have logical operators, we have relational operators. Here is our order of precedence for how those operators are all grouped together if we have a whole bunch of them in a row. So for example, if I have 5 greater than 10 and 6 less than 15, or 12 plus 9 halves minus 4. We can see expressions like that all grouped together. We can see how they're put together using this order of operations. So parentheses always goes first, naturally. Then we have exponentials, and then not. So the logical not is evaluated. And then we have multiplication, division, addition, and subtraction. And then we have relational operators. These ones have higher precedence than equality operators. And then we have logical and logical or, and then these double and double or, and then assignment. So in general, it follows math first, then relational comparisons, and then logical comparisons, where the not is evaluated in the middle of math. Okay, but that's generally the flow, but assignment is last. So the last thing you do is evaluate this expression and then assign it into the variable. That's why this side is evaluated first and the answer is stored in the variable on our left-hand side. So make sure you guys pay attention to the order of precedence or order of operations, follow the precedence rules in order to make sure that your expressions evaluate appropriately, especially when it comes to math, and now including relational and logical operators. Okay, here's this little chunk on what's called logical indexing. This is very important. It will show up on your homework, it will show up on the exam. It's really only a tiny amount in here, but it's really important and really crucial that you understand logical indexing, and we'll go over examples in class. I'll go over an example in a video. But the key thing in here, in logical indexing, is that we can go ahead and use logicals in order to extract or modify variables in an array really easily. So we have the two-hand side of our equal sign, right? We have, where do we want to put things? And what to put there. Now, instead of it just being specific locations, now we can talk about specific numbers inside of our array. So rather than saying what to put there or where to put things, now we can start to say, okay, rather than just in these locations, but we can say change all the values greater than 50 to 0. Or change all the values between 10 and negative 10 to 100. Or do some math. So change all the values greater than 50 and multiply them by 2. So we still have a, and then we have brackets equals something. So we want to modify these values. But like I said, rather than locations, we can say where a is greater than 50. So now we're saying specifically, change all the values according to this expression, according to this question that we're asking. And what are we going to change them to? A greater than 50 times 2. So that's what that would look like. And this is really powerful, really important. It takes a bit of time for students to understand this. But what's going to happen is this here results in what's called a logical array. Remember, if I take an array and I compare it with a value, it's going to create an array of the same size that has ones and zeros in all of those locations, saying whether or not it's true and whether or not it's false. So here in this logical array, when I say a parentheses logical array, then it's going to take all of the places where it's true, in this array, and modify them according to what's over here. And like I said, we will go over lots of examples, but that's the general idea. Where do we want to put things? What do we want to put there? Rather than it being specific locations now, we can change it based off of a question that we're going to ask. Last thing to talk about in this week is branching. So talking about how we actually make those decisions. So what I've talked about up here in all of these expressions, in all of these operators, that's how we ask questions. But down here is now what can we do with those questions? So a conditional or branching statement, there's two different kinds in MATLAB, if and switch, is a group of code that allows a program to decide whether or not to execute one group of code over another. Conditional expressions is the technical name for our questions, and that's what we're asking. Those are our true false answers based on what comparisons we're making with our variables. Keep in mind, whenever we ask these questions for branching statements, it needs to be scalars. So we always do an if statement or a switch statement based on a single true or false. We're never going to do it with an array of values. So we always need to work with it in terms of scalar values. Then what happens is if we have this decision, we ask a question. That question is true. That comparison is true. That conditional is true. Then we're going to execute some code corresponding to that question, and then skip everything else. So an if statement is used all the time. It's used all the time, where it looks something like this. We start with the keyword if, and we have an end. Every if has an end. Every switch has an end, just like every function has an end. But here's our question. So I'm going to say if, conditional expression, if this question is true, if this comparison is true, then here's my code to execute. If it's false, I'm going to skip over the code. So my question is either true or false. True, I execute the code. False, I skip the code. This code is always indented. It's always indented. In MATLAB, you can press Control plus I. For Mac users, I think it's Command plus I. There's also a button in your ribbon up at the top to automatically indent. But this indentation indicates that this code corresponds to this conditional, this question. So that's really useful. We can have more than one question to ask. So here, for example, I have an if, I have an else, and I have an and. And else is the default. So here I'm asking, here's a question, is it true or false? If it's true, I'm going to execute this code inside. If it's false, I'm going to jump down to my else, and I'm going to execute this code. So you can see that in the comments. So if this conditional is true, I'm going to execute this code in here. If it's false, I'm going to execute the code in my else. So here I have two options. It's either this or this, depending on my question. I can also have other options as well. So here I have if, else if, else if, else. Else is still the default. But these else ifs allow me to ask different questions. So here's question 1, here's question 2, here's question 3. And what I'm going to do is I'm going to ask one question at a time, starting with my first question. So if question 1 is true, I execute this code and then I exit. But if question 1 is false, then I'm going to go ask question 2. If question 2 is true, I'm going to execute this code and exit. But if question 2 is false, then I'm going to go ahead and ask question 3. If question 3 is true, I'm going to go ahead and execute this code and exit. If question 3 is false, then I'm going to go to my else, execute this code, and exit. So when it comes to an if statement, we are choosing between one of many blocks of code. So I do want to point out that the else is default and optional. You do not need an else. So it's 1 or 0 blocks of code that we're choosing between. It depends on how you design your questions and how you design your if statement. There's lots of ways to put together an if statement. But in general, an if statement is deciding between one of many blocks of code. The block of code that's going to be executed is the first true question block. So you can have more than one question that's true for a given value. You can have more than one comparison that's true. The if statement will always get to the first one that's true given your order. So starting with this one first, and then this one, and then this one, and however many else ifs you have. So keep that in mind when you're designing your if statements. But an if statement is used at any time, and it's deciding to execute something or not execute something. So depending on the comparisons you're making, you're choosing between one of many blocks of code. In general, if statements should be designed or written to minimize logical tests and remove redundancies. There's many ways to design a branching statement, even for a really simple problem. But in general, these are the 3 rules we can go ahead with in order to help write our code. So first, determine how many mutually exclusive paths there are. What are your options? So how many different answers are you going to have? How many different answers can you have? And then if required, so this does not always happen, we're going to order them from most restrictive to least restrictive. And this helps when you're doing like ranges. So comparing ranges of values. And then we can write our conditional statements, because these are the ones that go next to our if. So write our questions. To write our conditional statements, to write our branching. So an if statement we can write anytime. An if statement is our generic branching statement. There's also an alternate branching statement called a switch statement. And this can only be used when we are testing one variable for equality. So is x equal to 0? Is x equal to 1? Is x equal to 2? Is x equal to 3? This works for text and for integer values. So we want to be really careful when we're using a switch statement. We want to make sure that we can actually use it. So integers, characters as well. Characters are technically integers, but we'll say text and integer values for equality. The switch statement looks like this. We start with the keyword switch. Every switch has an end. Just like every if has an end, every function has an end. And then we have cases. So rather than else ifs, we have cases. We can have cases followed by a single comparison, or we can have cases followed by several comparisons. But what we're going to do is we're going to go ahead and check to see if this variable is equal to our cases. So it's checking, is our variable equal to one of these? Is it equal to this or this or this? If it's not, it's going to check, is it equal to this, this, or this? If it's not, it's going to check if it's equal to this, and then keep going. Otherwise, here is our default. That's our default when it comes to a switch statement. Instead of an else, it's a otherwise. But here we're checking for equality. Is my variable equal to case 1, case 2, case 3, case 4? And then we can check for multiple values with the or. So here, if there's more than one case, there's an or, not an and. And last thing to mention is any valid code can go inside of an if statement or a switch statement. So any valid code can go in that code block. This is known as a nested structure. So here's an example of an if statement inside of an if statement. Indentation is super important in this instance because I can see that all of this corresponds to this if. This corresponds to this else. And this if gets this code block. So it's always important to keep track of what's happening inside of your code blocks, inside of your code that's going to be executed. Because if this question here is false, all of this is skipped and ignored, and it will jump down to the else here. However, if this question here is true, it's going to go ahead, execute this, and then check this if statement here. Here's another question. call question 2. If this is true, it's going to execute this, then jump out to this end, and then jump to this end. If this question 2 is false, then it skips this inside code block, jumps straight to this end, and then jumps straight to that end. So it's really important that we have proper indentation so we can see how all of our if statements and switch statements are related to each other.